Hey guys, welcome back. Expanded octets. So molecules with 12 electrons around the central atom. These are expanded octets. All right, so we know these molecules exist. They violate the octet rule, and that's okay. Let's deal with it. Let's go. So electron count for sulfur hexafluoride. 6 electrons for sulfur plus 6 times 7 electrons. So that would give me 48 electrons. Who's in the middle? Well, it's not fluorine, so it's sulfur. So I'm going to put an S, an F, and then just evenly space these fluorines around. First thing we're going to do is bond. 2, 4, 6, 8, 10, 12. I can have up to 12, so that's okay. Then 14, 16, 18, 20, 22, 24, 26, 28, 30. And some of you guys already know that 6 times 8 is 48. And you know that all these fluorines will have 6 dots around them. And that'll be good. And that's SF6. Just like that. The molecule exists. It's actually used in a type of fire extinguisher. So 12 electrons, but it works. Xenon tetrafluoride, another compound that actually exists. 8 electrons for xenon, plus 4 times 7 electrons for fluorine. So that's what, 28 and 8, 36 electrons. So xenon in the middle, because who's not in the middle? Fluorine. I'm going to do 4 corners. A lot of times we'll do it this way. You can do north, south, east, west. That works out great too. 2, 4, 6, 8, 10, 12, 14. So if you notice, it doesn't matter which fluorine you start filling the terminal atoms in it. I'm trying to go around, so it doesn't matter where you start. I do not care. You can go to another atom, and then another atom. It doesn't have to go in order, right? We're just doing the terminal atoms. There's no right or wrong way. Just don't forget any. So that's 32 electrons, right? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. 8 times 4 is 32. I have 36. I have 4 more electrons. Where do they go? Well, extra electrons go on the central atom as lone pairs. And there you go. There's XEF4. 2, 4, 6, 8, 10, 12 electrons around a xenon. H2SO4. Ooh. All right, now we're getting to a little more complicated. How is this done? How is this done? Well, first thing we do is the electron count. 2 times 1 electron plus 6 electrons plus 4 times 6 electrons. That's basically 5 times 6. 6 times 5 is 30. And then 2, so 32 electrons. How is this arranged? Well, sulfur. A lot of people would throw sulfur in the center. So S, 1, 2, 3, 4, 5, 6. Bond. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. That doesn't work. That doesn't work at all. Oh. Well, that's a problem. How do we do this? I'm going to take a step back, and this is another reason why I am big on having you guys know the polyatomic ions. Really big on it. Why? Because this is sulfuric acid. Comes from sulfate. because we're going to learn something right now about this. Oh. So let's talk about sulfate. Now, it's really nice because I can just erase. We have two H pluses and SO4 2 minus. So let's draw this SO4 2 minus. SO. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. All right. Why? Well, I have 6 electrons plus 4 times 6 electrons plus the 2 electrons. So I still have 32 electrons. And so that would be how it's distributed, isn't it? Okay, now I did not minimize formal charge. Let's minimize the formal charge. Each oxygen has 1, 2, 3, 4, 5, 6, 7. Each oxygen has 7 valence electrons. However, it only brings in 6, so oxygen is minus 1. Sulfur has 2, 4, 1, 2, 3, 4. Sulfur only has 4. It brings in 6. So what I can do is I can double bond 2 of the oxygens. Whether you're doing this, it doesn't matter which 2. They can be across. That's a minor detail in our class. So now the formal charge, 0 for this oxygen, 1, 2, 3, 4, 5, 6, has 6, brought in 0. Sulfur, 1, 2, 3, 4, 5, 6, 0. Oxygen, 2, 4, 6, 0. Minus 1, minus 1. Great. Now we're going to add our 2 H pluses. Our 2 H's. And so what's important to notice is that these H's are going to be on the oxygens. So all these ternary oxyacids, even though it's written H2SO4, the H's are technically bonded to the O. So there's sulfuric acid. You could have actually gotten there with formal charge, right? But that's how you put it together. So as they get bigger, it gets a little more complicated. So here sulfur has 2, 4, 6, 8, 10, 12 around it as well. And that's the Lewis structure of sulfuric acid. Let's go on to triiodide. 7 electrons for iodine. 3 times 7 plus the 1 equals 22 electrons. So how is this arranged? Well, we're going to find out. It's 3 iodines in the middle, in a row. 1 I in the middle. 2, 4, 6, 8, 10, 12, 14, 16. That's quite a bit left. Well, where do extra electrons go? Central atom. 18, 20, 22. 2, 4, 6, 8, 10. So iodine has 10 electrons around it. It has 3 lone pairs and 2 bonding pairs. That's kind of crazy. That's how it looks. That's exactly how it looks. Last one, bromine trifluoride. Electron count for bromine trifluoride. We have bromine has 7 electrons plus 3 times 7 electrons. That gives me 28 electrons. Who's in the middle? Well, it's not fluorine, so it has to be bromine. We are F, F, F. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. There's some more electrons. 26 on the central atom and 28 on the central atom. And there you go. There's bromine trifluoride. Bromine has 2, 4, 6, 8, 10 electrons. Some examples of expanded octets. Take care.